So in this session, we will discuss questions related to the Newton laws of motion. So the first question, what is meant by Newton's first law? So what is meant by Newton's first law? And it is of 2 marks. So first thing you have to mention that object will be at rest or it will move with a constant speed. And the second mark, when the resultant force is zero or no unbalanced force acting on the object. So object remain at rest or moves with constant speed. And what is the second mark? It's when there is no resultant force, or you can mention no unbalanced force acting on the object. This is how you will score. Well, you will get the 2 marks. Newton's third law identifies the pairs of forces. State two ways in which these pairs are identical and two ways in they are different from each other. So Newton pair forces, we have to write similarities and differences. So what are the similarities? They will have the same magnitude. The two forces, the pair forces, will have the same magnitude. There will be same type of forces. Or they will act at the same time. These are the, but we have to write only two of them. And what are the differences? How these pair forces are different from each other? They will act on different objects and act on opposite directions. So they will act on different objects and it will have different direction. So example, if you say an object is lying on the floor, so there is a downward force of the object, contact force. The downward force of the object by the object on the surface balances with the upward force by the surface on the object. So there, and even in similarity, you can mention they're acting in the same line. Their directions are opposite. They're acting on different objects. Like the force of the object is acting on the surface, and force of the surface is acting on the object. So this is how we say they are similar in terms of magnitude, type, acting at the same time, acting on the same line, and how they're different from each other. They're acting on different objects and they're acting in different directions. One of the forces acting on the car is being described as follows. The earth exerts a downward gravitational force of 12,000 Newton on the car. Describe the third. So whenever the downward gravitational force on the car, because the earth is pulling, like a car is there on the surface of the earth. So this car is being pulled by the earth with a force of 12,000 Newton. So what will be the pair force? The car will also pull the earth with the same force but in opposite direction. So it will be also be 12,000 Newton. So describe its third law pair force. So how we describe the third law pair force? So the car will exert the upward force on earth of magnitude 12,000 Newton. So same force but in opposite direction, which create a Newton pair force. In this question, the photograph shows a physics teacher carrying out a demonstration related to vertical motion. So as you can see, a coin A is placed on the top of a smooth ruler. Another coin B is there, as you can see, which is placed on the table. One of the hand, the finger is actually acting like a pivot. And as a teacher rotate this, what will observe the coin will fall vertically towards downwards toward into the, and this will follow a projectile motion. So when we compare, this is a top view, but if we compare the side view, like this is a table, there's coin A placed on the ruler and coin B is placed. So the moment we release them, the coin B will follow a projectile motion and coin A will fall vertically. Coin A fall vertically where B pushes horizontally. Both coins hurt to strike the floor at the same time. Use the Newton's first law to explain why coin A has no horizontal motion. Why this coin A does not have any horizontal motion? We have to use Newton's first law. So initially what happened, as you can see, initially the coin A was at rest. And the moment we remove the ruler, as you can see, the moment we remove the ruler, the only component of the force which is there is the vertical. It does not have any horizontal component of the force. So that's why horizontally there is no acceleration, or there is no horizontal component of the force which can cause acceleration. Only vertical component, the weight is there, that cause the acceleration. So how we write this answer of 2 marks, we'll mention coin A, which is initially at rest, does not have any horizontal component of the force. Only and it has only vertical component, which is the weight. So what happened the moment it is released? Because according to Newton's first law, if there is no resultant force, there is no acceleration. So if there is no horizontal force, that's why there is no horizontal acceleration. So if there is no horizontal force, there is no acceleration. That's why it will fall only vertical. Is it clear? This part? Anyone having a doubt? Then the next question, explain how this demonstration shows the independence of vertical and horizontal motion. So how this shows that horizontal and vertical motions are independent of each other, does not depend on each other. As we can see, the coin A fall vertically and coin B follow a projectile motion. It is having both horizontal and vertical components. This is a trajectory followed by coin B, but both hit the ground at the same time, as they mentioned in the question, that we hear the sound at the same time. So how we can show that horizontal and vertical component are independent of each other? Because they hit the ground at the same time. shows that both have the same vertical acceleration, and although B or coin B is having both horizontal and vertical components. So coin B is having both horizontal and vertical. It is moving horizontally as well. It is moving vertically downward. But coin A is only moving vertically. So both have coin B is having both component, whereas coin A is having only one component. But because both coins took the same time to hit the ground, so what it shows the horizontal and vertical component does not depend on each other. Means if one of the object is falling vertically, another one is falling a projectile motion, a trajectory in which we neglect the air resistance. So the horizontal and vertical, even though the second object is having both component, but it will always take the same time to hit the ground, assuming that acceleration is constant and the air resistance is not affecting the motion. That's our assumption. Is it clear this part? So this part is actually related to the projectile motion in which we discussed the horizontal and vertical component does not depend on each other. Another question, during a lesson on Newton's law of motion, a student says we do not really need to bother with Newton's first law because it is included in his second law. Like we don't have to bother about Newton's first law because it is included in the second law. State the Newton's first two laws of motion and explain how the second law is included in the first law. And it is of 5 marks. So first we have to write the statement of Newton's first law. According to Newton's first law, an object, if it is at rest or object is moving at a constant speed, it continue to move with a constant speed until or unless unbalanced force act on the object. So according to the first law, the object moves with constant speed or remain at rest unless unbalanced force act on it. So that is the Newton's first law, which state that if there is no resultant force, the object will remain in its state or it will not change the state. What about the second law? The Newton's second law states the object accelerate until unbalanced force act on the object. And it also states that the acceleration is proportional to the resultant force if mass is kept constant. So resultant force is acceleration proportional to resultant force if mass is kept constant. And then how the, so 2 marks you will get to write the Newton first law, 2 marks you will get to write the Newton second law. Then how you relate the first law with second law? So how first law and second law is related? Because first law, no acceleration when no resultant force. And the second law, there will be acceleration when there is the resultant force. So we relate the two laws, that if, like, basically it's like one statement: if there is no resultant force, there is no acceleration. If there is resultant force, there is acceleration. So no resultant force is a part for first law, and resultant force is a part for the second law. Is it clear? Is it clear to everyone? Okay, another question, and it's of 6 marks. So you can see the weightage for these questions. And the static question means the terminologies which you are using to answer these questions, it must be scientific terms. Einstein imagined a person in a large box without a window. So if a person is there in a large box without a window, he suggested that there is no way to see outside. The person could not tell whether he's experiencing the gravity of the earth or he's in a deep space far up from any effect of the gravity, but being accelerated at a rate of 9.81. So this is the Einstein explanation about, if, like, there are two persons, one is stationary on the earth and another one is there which is accelerating in a deep space. So he suggests that the one he's like, if there is no window in a large box, then they cannot tell in a deep space fast. The person could not tell whether he's experiencing the gravity of the earth or whether he's in a deep space which is accelerating or having an acceleration same as 9.81. Account for Einstein's suggestion by explaining in each case what a person standing in the box would feel through their feet. You may also assume that the person has a mass m. So what about the person who's at rest on the earth? So weight of the person, the gravitational pull will act downward, and if there's a gravitational the downward force is there, the surface will also apply an upward force, the normal contact force. And because he's stationary on earth, so if stationary on earth, acceleration will be zero, or we can say the resultant force will be zero. So if the resultant force is zero, so we can say W minus R is equals to zero, or we can say W is equals to R. So the resultant force on the object is zero. So when the resultant force on the object is zero, what happened? This person who's stationary on the earth, he will not feel any force. Is it clear, this part, the first part, that the person who's stationary on the earth surface inside a box without any window, his weight is acting down, there's a normal contact force is acting up. Because he's not accelerating, he's at rest, so he will not experience any resultant force. Resultant force will not be there, but he will feel the upward force, and that upward force will be equal to his weight. So he will not feel any resultant force. This is about the resultant force. Or we can say if his weight example is 300 Newton, so the surface will also apply a force of 300 Newton. So the reaction force, the contact force will balance with the weight. So person feels an upward force equal to its weight. Now what happened? So there is no resultant force, but there is a force he experiences, because the resultant force is zero, but there will be a force, weight acting downward, so there should be an upward force that matches with the downward force. So he will feel a force which is equals to the reaction force equal to weight, and resultant, he will not experience any resultant force as it is not accelerating, but there will be an upward force. But what about the person who is in a deep, accelerating in a deep space, which is acceleration 9.8, means acceleration is due to gravity. So when the box is accelerating, what about the acceleration of a person? The acceleration of a person is same as acceleration of the box, so that will be 9.8 as well. So we have the formula, and there is no downward force because there is no gravitational force in a deep space, so there is no downward force. That's why there is no normal contact force. So here the resultant force is equals to ma. So resultant force is equals to mass is m, and gravity is, the acceleration is due to gravity, which is 9.8. So we can write G. So what he experienced, he is experiencing a resultant force of ma. So he will also experience the same resultant force, that is equals to mg. So both person will experience the same resultant force. That's why Einstein suggests for this object resultant force is zero, but the upward force is equals to the weight. And for another person who's accelerating in a deep space, he should have a resultant force, and that resultant force is equals to mg, or we can say that resultant force or upward force is also equal to his weight. So both, that's why the Einstein suggests that if the person is there in a large box without a window, he suggests that we cannot tell whether a person is on the earth or person is accelerating on a deep space, in a deep space at acceleration due to gravity. Is it clear, this question? So I'll repeat in short. Basically what happened, person who's on the earth, his weight is acting downward. So the surface will apply an upward force. Resultant is zero, but what about the upward force? The upward force is equals to his weight. But for a person who's inside a box, which is having acceleration same as 9 or due to gravity, so there is no downward force, but the resultant force is equals to ma, and because he's accelerating, so the resultant force is equals to mg, and mg is equals to weight. So he will also experience the force which is equals to his weight, and the person on the earth also experience the force equal to weight. That's why we cannot tell whether we are on the earth stationary inside a box or we are accelerating in a deep space. Another question related to Newton's law. Opposite poles of a magnet attract one another. Using this principle, student try to design a toy car that could be self-propelled. Like what he did, he placed a magnet in front of the car and he's holding another magnet. His design is shown below. Magnet A is attached to a body of the toy car, and magnet B is suspended from a driver's hand to the rigid rod, and magnet A and identical to magnet B. The student stated as long as the opposite poles of a magnet are facing, the attractive force cause a force on the toy car and start to move. Explain why in practice this could never work. So why this could never work? As we know, according to Newton's law, action and reaction forces are equal but opposite in direction. So if magnet A is attracting magnet B, the magnet B will also attract magnet A as well. So magnet A exert force on magnet B. So magnet A is exerting force on magnet B and magnet B is exerting force on magnet A. They will be same but in opposite direction. And this magnet is actually attached to the person. So this person is also experiencing a same force. So if I say, if this is 30 Newton, this is also 30 Newton because a person is holding. So the force on this person is also 30 Newton. So why this car will have a zero acceleration? Because there is no resultant force on the car. So when you check this car, a 30 Newton force on magnet A and a 30 Newton force is there on the person which is inside the car. So what it create a resultant force of 0 Newton. That is why this principle, this in this case, it will never work, as there is no resultant force on the car. The two forces which are acting cancel out each other and it appear to be a balance force. Is it clear, this example? Because according to Newton law, there should be two different objects, but as you can see, the magnet A and magnet B are attached to the same object. Like a person inside the car is holding magnet B and the magnet A is attached to the same car. That's why this principle is not, or this will never work. Is it clear, this example? A lorry accelerates from rest and there's a box of mass 200 kilogram. The box is not tied to the lorry. The lorry accelerates from rest to a speed of 15 meters per second and cover 39 meters. Show that the acceleration of a lorry is about. So we have the initial speed, which is 0. We have the final speed and we have the distance. So we can use equation of motion. 2as is equals to v square minus u square. So 2 acceleration we don't know. The distance is 39. The final speed is 15 and the initial speed is 0. So 2 into 39, that is 78. So it will be 78. A is equals to 15 square, which is equals to 15 square, and then A will be equal to 15 square divided by 78. The acceleration will come out as 2.88, which is about 3 meter per second square. And because this, if the truck acceleration is 2.88, as the box is also on the truck, so the box will also have the same acceleration, which is 2.88 meter per second square. Because like example, if there is a bus, you are inside the bus and the bus is accelerating, it means your acceleration is same as acceleration of the bus. Because the next part is related to that acceleration, we have to use that to work out the frictional force. So the maximum frictional force between the lorry is about 630. Explain why this limits the maximum acceleration of a lorry without the box falling off. Answer should include a calculation. So here, because as it is accelerating, the friction will try to oppose the sliding down of the box. So friction is acting in this way. Because, for example, if you are inside the bus and the bus suddenly accelerates, so you tend to lean or move backward. So this box also tend to slide backward. So the friction is opposing. The friction is 630 Newton. So frictional force is actually responsible for resultant force. So resultant force is equals to MA, and resultant force is the frictional force, which is 630. The mass of the box is 200, that is given in the first part, and acceleration. So 630 divided by 200. So when we solve 630 divided by 200, so acceleration will be 3.15 meter per second square. So means this truck maximum it can have an acceleration of 3.15 meter per second square. If it is having acceleration more than 3.15, then the friction is not able to support this box, and this box will slide down, and that's why it limits the speed at which the or acceleration at which the lorry is traveling. Is it clear this part? So we have to find the acceleration, and we have to say that this could be a maximum acceleration which the lorry can have. It cannot have acceleration more than 3.15, otherwise the box will slide down. Once a lorry reaches its destination, the back of the lorry is tilted at an angle theta. The three forces, the free body force diagram is given: the normal, contact force, the friction. State an expression which we can use to show the component of the weight. So when we take the axis on inclined surface, so the angle of the inclined surface is same as the angle of weight with an axis, and the component of the weight which is acting with an angle, that is w cos theta, and against the angle will be w sin theta. So r is matches with w cos theta. So parallel component which is parallel to the inclined surface, the back of the lorry, that is w sin theta, and perpendicular in this one 90 degree with the inclined surface is w cos theta. Then the theta is increased until the box is just about to slide down. The f is 0.32 r. Calculate the theta for which the box just slide down. So we have to calculate this angle for which the box just slide down. So we consider there is no resultant force acting. So from this r is acting upward, w sin theta is acting down. So we can say r minus w sin theta is equals to 0, because the upward force balances with the r minus w cos theta, not sin theta, because it matches with cosine theta. So r minus w cos theta is 0, or we can say r is equals to w cos theta. The friction is acting on above, means on the inclined surface, and w sin theta is acting to try to make this box slide down. So we can say the friction minus w sin theta is equals to 0. This because they are just about to slide down, or we can say still it is at rest. So, or we can say f is equals to w sin theta. When we compare these two equations, the value of f is given 0.32 r. So in place of f, I can write 0.32 r. So 0.32 r is equals to w sin theta. So this is what our equation 1, and this was equation 2. So if I substitute the value of r as w cos theta, so this will be 0.32. R is equals to w cos theta, and then w sin theta. W will cancel with w. Cos theta is multiplied, other side will divide, and sin theta over cos theta is tangent theta. So 0.32 is equals to tan theta. When we need theta, theta is equals to tan inverse 0.32. So when we take tan inverse 0.32, the angle at which the box is about to slide down, that will be 18 degrees. Is it clear, this example? So the mathematical equation, the substitution method, how to solve simultaneous equation, that is also important. The similar question we already discussed. A man pulls a box towards him. Identify the pair force that has the same magnitude due to, so the man is pulling the box and the box is pulling the man. So the pair forces are pull of the box, pull of the man on the box balances with pull of a box on the man. State one similarities and one difference. So how they are different, their directions are different, and how they are similar, their magnitudes are same. Then the angle between the pull of a man is 35 and the mass is 85. Show that the pull of a man on the box is about 400. The contact force is 620. This normal contact force is 620 Newton. The mass, the weight will be 85 into 9.8 because mg, and it is making angle 35. So this is 35. So the one which is with an angle, this will be cos theta, like I say f cos theta or f cos 35, and against the angle will be f sine 35. So 620 is acting up, f sine theta or f sine 35 is acting up, and weight is acting down. So we can say 620, which is acting up, plus f sine 35 minus the weight, which is 85 into 9.8, is equals to 0. Why 0? Because the vertical plane, there is no acceleration. So if there is no acceleration, the object, the resultant force on the object will be 0. So this will give us the value of F as 373 Newton. And then when you need friction, so how to get the friction? So F cos theta, after getting this F, so F cos 35 minus the friction will be 0. Why? Because horizontally there is no acceleration. Then the man increases his pull, the man and the box start to move together. Calculate the friction force between the ground and the man. So we have to calculate this frictional force between the ground. So basically, there's a frictional force on the box and there's a frictional force of the man. The friction force on the box that we calculated 310, and the frictional force of the man with the ground we are finding, and it is having an acceleration because I mentioned it is about to accelerate with an acceleration of 0.2. So this is having acceleration of 0.2. So we can say the friction of the man minus 310 is equals to ma. And what about this m? Because we are taking the whole system. So mass of the box plus mass of the man, when we add, that will be the total mass. So F minus 310 is equals to 80 plus 90, so 175 into 0.2, the acceleration. So this will give us the frictional force between the man and the ground. So this discussion already I have discussed in the topic force, motion and acceleration. So in the next session we'll discuss more questions from Newton's law. Any question related to the class today? Any question or a doubt? So I'll end the session and share this with you.